I want you to close your eyes for a second. Just picture the Caribbean.
Oh, that's easy. White sand and the turquoise water.
Right, exactly. You're probably seeing that pristine travel brochure version. Maybe there's a cruise ship docked way out in the distance.
Someone handing you a very colorful drink with a little paper umbrella in it.
Yeah, paradise.
It is, well, it's the modern definition of paradise, but that's a really surface-level view of what those islands actually are.
It really is.
Yeah.
So let's peel back that layer of the all-inclusive resorts. I want to zoom in specifically on the islands of Antigua and Barbuda.
Okay, zooming in.
And now we're going to turn the clock back.
How far back are we talking?
Oh, way back. We aren't going to the pirates or even to the arrival of Columbus.
Right.
We are going back thousands of years.
Before the very first human footstep ever disturbed that white sand.
Exactly. To a time when those islands were louder, wilder, and honestly much stranger than they are today.
A completely different world.
In this ancient version of Antigua, there's a creature moving through the underbrush. And it isn't a bird. It isn't a reptile.
Right, which is what you'd expect on a remote island.
Right. It's a mammal.
Yeah.
And it is not small.
Definitely not small.
We're talking about something the size of a large house cat, maybe even a small dog.
It's robust. It's furry.
And it is the undisputed king of the ground.
And here's the real kicker about this animal. It survived incredibly long odds just to get there.
Unbelievable odds.
It thrived for millennia. And then, in the blink of a geological eye, it vanished.
Poof, gone.
But that is not actually the strangest part of this whole story.
No, the strangest part is its current status today. Because usually, when we talk about extinct animals, you know, dinosaurs, dodos, the woolly mammoths.
We know their names.
Exactly. We know their names. We have the museum T-shirts. We have the lunch boxes.
The whole branding package.
But this creature, you can go to a museum right now today.
Like the University of Florida or the Smithsonian.
Yeah, and you can literally hold its skull in your hands. We have the bones.
We have all the measurements. We know exactly where it lived, what it ate, who ate it.
We have so much data. But if you open the official rulebook of zoology,
It doesn't exist.
it does not exist.
It's a biological reality, but legally, it's a taxonomic ghost.
So today, we're doing a deep dive into this ghost of the Caribbean.
I love that title.
A massive, extinct rodent that is technically completely nameless due to this bizarre bureaucratic loophole that has lasted for over 60 years.
We're talking about the creature that is known informally as Ekbletomys,
Ekbletomys.
or, as the scientific literature rather coldly prefers to call it, undescribed species B.
Undescribed species B. I mean, that sounds like a vitamin supplement, not a giant island conqueror.
It really lacks a certain grandeur, doesn't it?
It's a terrible name for a king.
It is. But the story behind that lack of a name is almost as fascinating as the animal itself.
For this deep dive, we're going to be heavily referencing a specific Wikipedia entry that details the taxonomy, the morphology, and the history of this creature.
And that entry is primarily built on the foundational work of a paleontologist named Clayton E. Ray.
Clayton Ray. He's really the central detective in this whole mystery.
He absolutely is.
Okay, let's unpack this. Because I'm reading the source material, and it sounds like something out of a Kafka novel.
It's very bureaucratic.
How can an animal be sitting in a drawer at Harvard, fully fossilized, fully described in writing, and yet the scientific community collectively says, nope, never heard of it?
To really wrap your head around that, we have to talk about the rules of the game.
Okay, the rules.
Zoology isn't just about going out into the field and finding cool bones. I mean, that's part of it, but it's also about paperwork.
Lots of paperwork.
There is an official governing body called the ICZN,
Which stands for?
the International Commission on Zoological Nomenclature.
Wow.
Yeah, they're basically the Supreme Court of animal names.
The Supreme Court of Taxonomy. I imagine their meetings are very lively.
They are incredibly precise, let's put it that way. But they have to be. Their job is to prevent total chaos. Think about it. If we didn't have strict universal rules, you'd have, say, 5 different scientists discovering the exact same species of beetle on 5 different expeditions.
And they'd all give it a different name.
Exactly. You'd have 5 different names in the literature, and no one would know that they were all talking about the same bug. Science would grind to a halt.
Okay, so I get why the ICZN exists. They need a strict code on what counts as a legally published name so everyone is on the same page.
Right. And that brings us to Clayton Ray.
Enter our detective.
So rewind the clock to 1962.
Yeah.
Clayton Ray is a PhD student at Harvard University, and he's writing his thesis on the rodents of the Antilles.
The Caribbean islands.
Yes. He's examining these subfossil and fossil collections from Antigua and Barbuda, and as he's looking at these bones, he realizes he's holding something entirely new.
It's not just another rat.
No, this is a monster rat. It's totally distinct from anything else on record.
So he does what a good scientist does. He does the work.
He does a brilliant job, actually. He measures the skulls, he painstakingly describes the teeth, the morphology. He figures out exactly where this giant fits in the mammalian family tree.
He maps it all out.
He maps it out, and he names it. He gives it the species name Oryzomys hypenemus.
Oryzomys hypenemus.
And he even creates a brand new subgenus for it, which he calls Ekbletomys.
So he typed this all up.
He types it all up, gets it bound into his thesis, and he submits it to the faculty at Harvard.
He defends it, gets his PhD.
He gets his doctorate, and that physical thesis document goes right into the Harvard Library archives.
Okay, so case closed, right? The giant rat has a name. It's written down at Harvard.
You would really think so, but here's the massive loophole.
I'm bracing myself.
According to the International Code of Zoological Nomenclature...
The Supreme Court.
Right. According to their rules, a university thesis, especially one from 1962, is not legally considered a published work.
Wait, hold on. It's sitting in the Harvard Library.
Yes.
Any researcher can walk in, request it, and read it.
They can.
Other scientists have literally cited it in their own papers. How is that not considered published?
It all comes down to their strict definition of public dissemination.
Public dissemination.
The ICZN logic is that a thesis is essentially an internal academic document. It's a final exam for a student.
An incredibly long final exam.
Exactly. But it wasn't printed in a recognized scientific journal. It wasn't distributed to thousands of libraries and universities globally.
It wasn't put out for the mass scientific public.
Right. In the legal taxonomic sense, it wasn't made formally available.
So because he didn't take that specific chapter of his thesis and mail it off to Nature or Science or the Journal of Paleontology...
Names don't count.
That is wild.
Because he never formally published that exact taxonomic description in a wide release format, the names Oryzomys, hypenemus, and Ekbletomys are legally considered unavailable names.
Unavailable.
It's like a squatter. It's living in the house of taxonomy. Everyone knows it's there, but it doesn't actually have the deed to the property.
That seems... I mean, I get the need for rules, but that just seems incredibly pedantic.
It's deeply pedantic.
We've known about this animal and its proposed name for over 60 years. Everyone in the field knows what Ekbletomys is.
They do, but science relies on that pedantry to function consistently across centuries and across language barriers.
I suppose.
But you're right, it does leave us in this weird, frustrating limbo where we essentially have to use the name in quotation marks.
Which is why we're calling it a ghost species.
Exactly. It's fully visible to anyone who opens the drawer, but legally, on paper, it's invisible.
Well, ghost or not, I really want to talk about the name that Clayton Ray tried to give it.
We should.
Because usually when you read scientific names, they're just dry Latin descriptors, right? Like large foot or red head.
Very literal.
But Ray got surprisingly poetic with this one.
He really did. He wasn't just describing bones. He was telling a story with the etymology.
Let's break that down. Start with this species name.
Okay. The species name is hypenemus.
Hypenemus, which means what exactly?
It derives from the ancient Greek word hypenemus.
Okay.
And that translates directly to Leeward.
Leeward, as in the Leeward Islands.
Exactly. Geographically, Antigua and Barbuda are part of the Leeward Islands chain in the West Indies.
So he's anchoring the animal to its physical home right there in the name.
That's right. But the subgenus name, Ekbletomys, that's the one that really paints a vivid picture.
Ekbletomys. It's a portmanteau, right?
It is. It's a combination of two Greek words, ekbletos and phlis.
Okay. Well, I know moose is the standard root for mouse.
Right.
What is ekbletos?
Ekbletos means cast up or thrown out.
Cast up.
So put it together.
The cast up mouse.
The cast up mouse.
That is so evocative.
Mm-hmm.
I mean, the cast up mouse, it immediately makes me think of a shipwreck or a survivor washing ashore on a piece of driftwood.
Which is precisely what Ray intended when he chose it.
Really?
Yes. He chose that specific imagery because it hints at a very specific scientific theory, the rafting theory.
The idea that this animal didn't just walk across a land bridge to get to Antigua.
No, it was washed ashore. It was a literal castaway.
We are definitely going to get into the details of that voyage. The source material calls it a Sinbad voyage, which is Just a fantastic phrase.
It's an epic journey.
But before we send our giant rat out to sea, I think we need to get a much better handle on what this animal actually looked like.
Physically, you mean?
Yeah, structurally. Because earlier you said it was the size of a large house cat.
Give or take, yes.
But when I say the words rat or mouse to you, I think most people, myself included, have very specific, ingrained image.
Sure.
We picture a subway rat. We picture a pest. Something small, skittish, darting along a baseboard.
Right, and you need to completely erase that image from your mind for this.
Erasing.
This is not a subway rat. Ekbletomys belongs to a group known as the Oryzomys.
Oryzomys.
The common name for that group is the rice rats.
Okay.
But even within the rice rats, Ekbletomys was an absolute giant.
So in the world of Caribbean rodents, this was basically megafauna.
It was the largest known Oryzomys.
How big is megafauna when we're talking about a rat? Give us a comparison.
We often compare its scale to another famous extinct Caribbean giant called Megalomys dismarestii.
Megalomys. Megamouse.
Exactly. These animals were incredibly robust. We are talking about a body length that could potentially be over a foot long, and that's not even counting a very long, thick tail.
Wow.
They were heavy, muscular creatures. If you saw one of these walking around today, your brain wouldn't immediately register eek, a mouse.
What would I think?
You'd probably think, is that a beaver? Or maybe a huge muskrat?
It had real physical presence.
It had undeniable presence, and we know this because of the skull.
The source material goes into a ton of detail about the exact skull measurements.
Yeah.
Millimeters and ratios.
It gets very granular.
And I know, usually when we start reading off millimeter measurements of old bones, people's eyes tend to glaze over a bit.
Oh, absolutely. It sounds like dry data.
But in this case, those specific bone measurements are everything, right? They're the only way we know for sure that this isn't just the exact same rat they found on the next island over.
That is the critical point. That's why the measurements matter so much.
Explain that.
See, the Caribbean historically had a few of these giant rats. We mentioned Megalomys, which lived on islands like Martinique.
Okay.
So if you're a slightly lazy scientist back in the day looking at a drawer of big bones from Antigua, it would be very easy to just shrug and say, they're all just big rats.
They're all the same basic thing.
Right. Big rat A on Martinique, big rat B on Antigua. Probably the same species, they just swam across.
But Ray didn't do that.
Ray looked closer. He looked at the holotype skull of Ekbletomys, the primary reference specimen, and he saw something fundamentally structurally different from Megalomys.
What did he see?
He zeroed in on something called the interorbital region.
Okay, let's help everyone visualize this. Where exactly is the interorbital region on a skull?
Okay, put your fingers on your own temples.
All right, fingers on temples.
Right between your eyes and your ears. That bridge of bone that sits just behind the eye sockets.
I feel it.
In most animals, and notably in the neighboring giant Megalomys, this area is quite broad.
It's wide.
Yes. It forms a wide, sturdy highway of bone connecting the face to the main brain case.
It's a wide forehead.
Exactly. But when Ray examined Ekbletomys, he found that this exact space is aggressively constricted.
Constricted how?
It is severely pinched inward. In fact, it is narrower than in any other rice rat known to science.
Pinched like he was put in a vice grip.
Morphologically speaking, yes. Imagine looking at the top of the skull and it looks like an hourglass.
Okay, I see that.
The waist of that hourglass, right between the eyes, is incredibly thin. That's the defining feature of the skull roof of Ekbletomys.
But why does that matter? I mean, is it just a cosmetic quirk? Just a case of, oh, well, this family has a narrow face.
No, not at all. In biology, especially in functional anatomy, form always follows function.
Okay.
That specific part of the skull, that interorbital region, is where the temporal muscles attach.
The temporal muscles, those are for chewing.
Yes, those are the big, powerful muscles that control the closing of the jaw.
Oh, interesting.
So when you change the architecture of that skull roof so drastically when you pinch it in, you are fundamentally changing the leverage and the structural integrity of the entire head.
You're changing how the machine works.
Exactly. You change the bite force.
So this narrow skull implies that Ekbletomys was eating differently than its neighbors, using its mouth in a totally different way.
It strongly implies a deep evolutionary divergence in their diet and behavior. You don't just develop a heavily pinched skull overnight.
It takes time.
That kind of major structural redesign takes hundreds of thousands, maybe millions of years of complete genetic separation.
Wow.
So that narrow hourglass shape proves beyond a doubt that Ekbletomys isn't just a Megalomys that decided to move to Antigua.
It's not a cousin who just hopped a ferry.
No, it represents a completely separate lineage, a totally different branch of the family tree that just happened to end up in the same geographical neighborhood.
That is fascinating. And there's another detail about the mouth architecture in the source material that really stood out to me.
The palate. Or the teeth.
Well, both, really.
Yeah.
The palate is described as being very short, barely extending past the third molar.
Right.
And the incisive foramen, which are those holes in the roof of the mouth, are also extremely short.
Yes, very compact.
But the teeth are what really caught my eye. The text says it had massive molars, but slender incisors.
Yes. The dental profile is incredibly telling.
So translate that for us. What does having huge back teeth but skinny front teeth actually tell us about what this giant rat was doing for dinner?
Think about teeth as tools in a toolbox.
Okay.
If you have huge, heavy, complex, grinding molars in the back of your mouth, you are built to process something tough.
Like what?
Maybe coarse, fibrous island vegetation, maybe really hard seeds. You are an anatomical grinder.
A grinder.
But then look at the incisors, the front-biting teeth. They are slender, relatively delicate for an animal this size. Now, compare that toolbox to the neighbor, Megalomys. Megalomys had noticeably smaller molars, but absolutely massive, thick, robust front incisors.
So Megalomys was using its front teeth as the primary tool.
Yes. Megalomys might have been cracking open really hard nuts or gnawing through tough wood, using those big front teeth almost like chisels.
So Megalomys is a cracker, and Ekbletomys is a grinder.
Exactly. And this tells us that even though they were both giant rats living on Caribbean islands relatively close to each other, they had evolved to fill completely different ecological niches.
They weren't just carbon copies of the same survival strategy.
Not at all.
It really emphasizes the idea that the Caribbean wasn't just this generic, uniform basket of tropical islands.
Each island was its own world.
Each one was a unique, isolated laboratory of evolution.
Laboratory is the perfect word for it. Isolation is what breeds biological innovation.
Because there's no gene flow from the outside.
Right. When you stick a small animal on a remote island and just leave it completely alone for 1,000,000 years, it starts to get weird.
It has to.
It solves the basic problems of survival in highly unique, localized ways. Ekbletomys solved the problem of surviving on ancient Antigua by becoming a massive, narrow-skulled grinding machine.
But to become a weird islander,
Yeah.
you first have to actually get to the island.
Ah, yes. The hardest part.
Which brings us to section 3 of our outline. The voyage.
The Sinbad voyage.
I just love that Clayton Ray used that specific comparison. Because if you pull up a map, Antigua and Barbuda are, well, they are not close to South America.
They're deeply isolated.
They're way up the northern end of the Lesser Antilles chain.
To get there from the mainland coast to South America, you have to cross a tremendous amount of open ocean.
So, logically, the most obvious theory for how a rat gets there would be island hopping, right?
Like stepping stones across a pond.
Yeah. You swim or drift a short distance from Venezuela to Trinidad. Then you establish a population there. Then maybe a few generations later, some wash over to Grenada.
Then St. Vincent, St. Lucia, Martinique, Dominica, Guadeloupe.
Right, just working your way up the chain, island by island, over thousands of years.
That is the intuitive theory. It feels logical and safe.
But Ray totally rejected that idea for Ekbletomys.
He did. He looked at the data and said, no, that's not what happened.
Why? I mean, taking it in short hops seems infinitely easier than doing it in one massive shot.
Ray looked closely at the geology and the bathymetry, the ocean depth of the region.
Okay.
Even during the Pleistocene epoch, the Ice Age, when global sea levels were drastically lower because so much water was locked up in the polar ice caps.
The islands would have been bigger then, right? More exposed land.
They were larger, yes, but the deep ocean channels between those islands, those remained. They were still massive, turbulent water barriers.
So it wasn't a land bridge situation.
Not at all. Ray calculated that to get from the South American mainland all the way up to Barbuda by hopping, this specific lineage of a rat would have to successfully cross at least 7 distinct deep-water ocean barriers.
7 times they'd have to brave the open ocean and win.
7 consecutive miracles. You have to launch a few individuals into the water, they have to land safely on the next island, establish a viable colony, thrive there, outcompete whatever's already living there.
And then eventually launch another population into the water to the next island.
Right, and Ray argued that the mathematical probability of doing that 7 times in a row, and crucially, without leaving any fossil trace of this specific lineage on the intermediate island.
Because we don't find Ekbletomys on Grenada or St. Vincent.
Exactly. To do all that without leaving a trace is statistically practically impossible.
So that's where the quote comes from.
Yes. Ray wrote that a series of successful sequential voyages like that would be, quote, no less wondrous than those of Sinbad.
So if they didn't hop from island to island, they must have rafted in one straight shot.
The rafting theory, also known in biogeography as the sweepstakes route.
Sweepstakes route. That name implies that most people who entered the sweepstakes lose.
Almost everyone loses. A sweepstakes route is a high-stakes, extremely low-probability dispersal event.
Okay, I need you to really paint the picture for us here. Because when you say rafting rat, my brain immediately goes to a cartoon.
Like a rat tying some twigs together with vines and raising a little leaf sail?
Exactly. Stuart Little on the high seas. What is a natural raft actually like?
Okay, you have to picture the great massive river systems of the South American continent.
Like the Orinoco or the Amazon?
Exactly. Imagine a massive catastrophic storm, a huge hurricane system, or maybe just unprecedented seasonal flooding high up in the mountains or the rainforest.
The water levels rise rapidly.
The river swells enormously, it becomes a torrent, and it starts undercutting its own muddy banks.
And the land just collapses into the churning water.
Huge, intact chunks of the forest floor. We are talking about dense mats of vegetation, tightly interlocked tree roots, fallen trunks, vines, thick soil.
Like floating islands of dirt and wood.
Yes, some might be the size of living room, some might be the size of a whole house, or even larger.
Wow.
These massive mats float rapidly down the swollen river and eventually get blasted right out into the open ocean.
And if our little rat ancestor just happened to be sitting on that particular piece of land when it gave way.
They're suddenly a passenger on an ocean voyage.
And I'm guessing this is not a luxury cruise.
It is an absolute nightmare.
I can't even imagine.
You are drifting helplessly in the strong Caribbean currents. The sun is beating down on you relentlessly.
Tropical sun, no canopy cover.
No shade, and worse, you have absolutely no fresh water.
Just whatever rain happens to fall.
Right. You are constantly battered by salt spray, which is dehydrating you further. You have to endure ocean storms that are actively trying to break your fragile raft apart.
And you have to survive this horrific ordeal for, realistically, how long?
To drift from the mouth of the Orinoco all the way up to the Leeward Islands, you are looking at weeks.
Weeks?
Maybe even a full month at sea.
A month on a floating tangle of roots with no water.
And here's the truly crucial, mind-bending part of the sweepstakes. It cannot just be one tough male rat that survives this.
Because one male rat does not build a population on a new island.
Exactly. You need at least a pregnant female to survive the trip. Or a breeding pair that somehow both make it.
The odds against that seem genuinely astronomical. It feels impossible.
It is effectively impossible in any human time frame. If you stood on the beach for a lifetime, you'd never see it happen.
Huh.
But here is the magic of deep geological time. If you give the impossible 1,000,000 years to happen,
It eventually becomes inevitable.
exactly. If you roll the multi-sided dice every single major flood season for 2,000,000 years, eventually one day you roll that perfect double six.
So one day, against literally all the odds in the universe, this battered, shrinking raft of vegetation
With a very thirsty, very traumatized pregnant rat clinging to it.
crashes onto the pristine white limestone shores of Barbuda,
Cast up.
Ekbletomys.
Now you see why he chose that name.
It hits so much harder now. It really was physically cast up by the sea.
And once they finally stumble off that raft onto the dry land, the entire game of survival changes.
They are in a totally new world.
And Ray actually had a very strong theory about exactly who was on that original raft, didn't he? Where they originally came from on the mainland.
He did. By closely analyzing the skull morphology, he pointed to a mainland species called Oryzomys albigularis as the closest living relative.
Okay.
Now, as a quick aside, taxonomy never sleeps, so today that specific species has actually been moved by geneticists into a new genus called Nephelomys.
Nephelomys.
But the common name is really the key detail here. They're known as the cloud forest rats.
Cloud forest. That sounds cold and wet.
It is. These are rats that live high up in the Andes Mountains and in the cool, high-altitude highlands of Panama and Venezuela.
They live in misty, chilly, wet mountainous forests.
Exactly.
It seems like the exact opposite of a sun-baked Caribbean beach on Antigua.
It is as different an environment as you can get, but they share the underlying skull architecture with our island giant.
So they have that same robust brain case, the specific crests on the bone? Yes. Which heavily implies that the small ancestor of Ekbletomys somehow washed down from those cool mountains during a flood, survived the brutal tropical ocean crossing, and then had to immediately adapt to a radically different, dry, scrubby climate on Antigua.
Talk about culture shock.
Yeah.
You go from the misty, cool Andes to a limestone scrub forest at sea level in the Caribbean.
It's extreme. And that intense environmental pressure, combined with the isolation, is what drove the gigantism.
The gigantism. Because they didn't start out giant.
No, the ancestor was relatively small. This transformation is an example of a classic biological principle called the island rule.
The island rule. Is that the one where small things get big and big things get small?
Exactly that. Foster's rule. If you are a large animal on the mainland, like an elephant, and you get trapped on an
You
island,
shrink.
right, you become a dwarf elephant over generations because there simply isn't enough food or land to support massive bodies.
But if you are a small animal, like a rat,
You get huge.
why? Why is bigger suddenly better for a rat on an island?
It's a combination of several factors. First and foremost, a total lack of predators.
Right.
On the South American mainland, if you are a rat, you stay small so you can hide in tiny crevices from jaguars, ocelots, foxes, eagles.
Everything wants to eat you.
But on ancient Antigua, there are no mammalian carnivores. None.
No wildcats, no wolves.
You are perfectly safe. You don't need to scurry and hide in tiny holes anymore. You can relax.
Okay, safety is one thing.
Second is competition. If there are limited resources and you are slightly bigger than your siblings, you can physically bully other members of your own species to get the best food.
Size gives you dominance.
And third, which is very important for our grinding rat, is metabolic efficiency. A larger body mass with a longer digestive tract actually helps you process the coarser, lower quality vegetation that you find on a dry island.
Which perfectly aligns with those massive grinding molars we talked about earlier.
Exactly. It all fits together.
So over thousands and thousands of generations, this little, terrified cloud forest refugee slowly puffs up into the giant, confident Ekbletomys.
And it essentially becomes the dominant terrestrial mammal of the entire island system.
I really want to talk about what that daily life was actually like for them.
The ecology.
Yeah, because reading the source material, we actually have a surprisingly vivid, detailed picture of the exact ecosystem Ekbletomys lived in.
We do. We know its neighbors.
And we know this thanks to, of all things, fossilized owl vomit.
Yes. The absolute glamour of paleontology.
That's amazing.
We honestly owe almost everything we know about the small, extinct animals of the Caribbean to the burrowing owl.
Okay, you have to explain that process for us. How exactly does an owl become the premier fossil collector of the Caribbean?
It's a field of study called taphonomy.
Taphonomy.
The study of how organisms die, decay, and become fossilized over time. And owls happen to be fantastic natural taphonomic agents.
Because of how they eat.
Right. Owls swallow their smaller prey whole.
Yeah.
Rats, lizards, little birds down the hatch in one piece.
Gruesome.
But their stomach acids, while they digest all the meat and soft tissue, they can't handle the hard stuff. They can't digest bones, teeth, or fur.
So they have to get rid of it.
So a few hours after eating, the owl regurgitates a dense, compact little pellet that contains all the clean, perfectly concentrated bones of whatever it just ate.
It's literally like a pre-packaged, perfectly curated museum exhibit just waiting to be found.
Precisely. And here's the key. These burrowing owls, Athene cunicularia, they tend to live in limestone caves or under rocky overhangs.
And they roost in the exact same spot year after year.
Generation after generation for millennia. So over thousands of years, these pellets just drop to the cave floor and pile up.
A mountain of data.
They break down, they get buried in the fine cave dust and sediment, and they preserve an absolutely perfect high-resolution snapshot of everything that was living and scurrying around in the immediate area.
So when Clayton Ray was doing his fieldwork, excavating those sites in Barbuda places with great names like Two-Foot Bay and Sufferers.
Or Mill Reef and Indian Creek over on Antigua.
Right. When he was digging there, he was essentially just digging through thousands of years of ancient owl toilets.
That is factually correct, yes. He described finding these distinct layers of red to yellow, unconsolidated sediment.
Loose dirt.
Loose, dry dirt that was absolutely packed with thousands of microbones.
So let's use that data to reconstruct the scene. Let's imagine it's, say, 2,000 years ago on Barbuda.
Okay.
We're standing outside the caves at Twofoot Bay at twilight. What are we seeing and hearing around us?
Well, first of all, it's a very busy, very noisy ecosystem. It is not quiet.
Okay.
Based directly on what we found in those owl pellets, the ground all around you is just alive with reptiles.
Lots of lizards.
Everywhere. You have Thecodactylus rapicata.
Thecodactylus, what is that?
The common name is the turnip-tailed gecko.
Turnip-tails.
They are these big, chunky, very vocal nocturnal geckos, so you hear them barking and clicking.
Okay, clicking geckos.
You also have fast-moving ground lizards darting through the leaves, like Pholidocylus grisoldi.
Try saying that 3 times fast.
I won't. And up in the branches, you have Anolis lichii, the large tree anoles. So there is just constant rustling in the dry leaves.
The ground is moving. And what about the birds?
The limestone cliffs and caves would be echoing. The pellets show huge numbers of seabirds nesting right there, especially shearwaters.
The puffinus species.
Right. And shearwaters, if you've never heard them, they make this incredibly eerie, ghostly wailing call when they return to their nests at night.
It sounds like a crying baby or something, doesn't it?
Like a crying baby or a ghost moaning. It's very unsettling.
Creepy ambiance.
Very. Now add the bats. The sediment is full of bat bones.
So the sky is full of them.
Huge swarms of mormoops and nettleless bats swirling around the cave entrances at dusk, catching insects.
And frogs.
Yes, the tiny whistling frogs, Aelepharodactylus johnstonii, calling constantly from the damp spots.
So it is an absolute cacophony.
It is wild.
We've got peeping frogs, squeaking bats, wailing ghost birds, clicking geckos.
And moving through the middle of all this noise and chaos is our giant Ekbletomys.
The king of the ground.
It's big, and compared to a skittish mainland rat, it's probably relatively slow-moving. It has no reason to hurry.
It's just lumbering along, foraging for tough seeds.
Maybe occasionally raiding one of those shearwater nests on the ground to eat an egg.
And of course, occasionally getting snatched up in the dark by a very ambitious burrowing owl.
Which, frankly, is impressive, because burrowing owls are not huge birds. They are relatively small, long-legged owls.
So taking down a cat-sized rat is a big deal.
It suggests the owls were probably mostly hunting the juveniles, the younger rats, because a full-grown, heavy adult Ekbletomys might literally be too heavy for a burrowing owl to lift.
But the sheer number of bones shows that this rat was a staple everyday food source.
It was the primary protein bar of the island ecosystem. Everything relied on it.
It really paints such a beautiful picture of a highly functional, entirely self-contained world.
It does.
You know, we so often think of islands as these fragile, broken ecosystems just waiting for humans to arrive and mismanage them. But this was working perfectly fine without us.
It was a perfectly balanced equation. The lizards, the giant grinding rats, the owls, the bats, they had all been dancing this intricate evolutionary dance together for thousands of years.
Until the music completely stopped.
Until the music stopped.
And this brings us to the harsh reality. Section 5 of our outline. The extinction event.
The end of the line.
We know, obviously, that Ekbletomys is gone today. The big question is, who killed it?
Well, in paleontology globally, we argue about extinction causes all the time.
Was it an asteroid? Was it a volcano? Was it climate change?
Right. But when you are studying the extinction of endemic Caribbean mammals, the answer is almost always painfully the same.
And the definitive evidence for that answer is buried right there in the dirt of those caves, isn't it?
It is written clearly in the stratigraphy, the physical layers of the cave floor.
Walk us through those layers, because this is fascinating.
Think of the cave floor deposit as a giant layer cake of history.
Okay, a cake.
The thickest bottommost layer of that cake is that yellow to red loose sediment we just talked about.
The owl pellet layer.
Right. That thick layer represents the old world. It is absolutely packed with the bones of Ekbletomys, the native geckos, the local bats.
And chronologically, how much time does that yellow layer cover?
It spans many thousands of years. It dates from the late Quaternary, the Pleistocene Ice Age, all the way up through the Holocene.
Meaning it continues right up through the arrival of the very first humans in the Caribbean.
Yes, that's a crucial point. The giant rat actually survived the first waves of human arrival.
Who were they?
The Amerindians, primarily the Saladoid peoples, they arrived in Antigua and Barbuda roughly around 2500 BCE.
So they shared the island.
They did. We actually find Ekbletomys bones mixed into the archaeological middens, the ancient trash heaps of these indigenous peoples.
Meaning they were hunting and eating the giant rats.
They were. It was a large, meaty animal.
But hunting them didn't wipe them out.
No. The overall population of the rats might have dipped slightly, but they had coexisted for a very long time. The indigenous hunting and agricultural practices were relatively low impact compared to what came later.
They didn't completely clear-cut the habitat.
Exactly. The giant rat and the indigenous humans shared those islands for over 3 millennia.
Okay, so looking back at our soil cake, we have this thick yellow layer showing humans and giant rats living together. Then what happens is you move up the dirt.
Then you hit a very sharp, very sudden line in the soil. The yellow dirt just stops.
Abruptly.
And right above it, sitting on top, you get a distinct layer of very dark, organic, rich sediment.
The dark layer. That sounds incredibly ominous.
It is the stark boundary line of the colonial era. And in that dark sediment layer, Ekbletomys just vanishes.
God.
The bones disappear completely. It is entirely absent from the upper record.
And what replaces it in that dark soil?
Rattus.
Rattus, the European rats.
Specifically Rattus, the black rat, and Rattus norvegicus, the brown rat.
The ship rats.
And crucially, Rattus does not cross oceans by rafting on random mats of vegetation.
No. Rattus travels comfortably in the holds of massive wooden sailing ships.
The sudden appearance of Rattus bones in that upper layer is the definitive geological marker for the arrival of Europeans post-1500 AD.
It is amazing, in a sad way, that the geology is that incredibly precise.
Yeah.
You can literally drag your finger up the cave wall and see the exact moment Columbus and the subsequent colonizers arrived.
It is a stark, devastating line in the earth. One world ends entirely, and a completely different one begins.
So why exactly is the European rat such an unstoppable killer in this scenario? I mean, think about it. Ekbletomys is a giant. It's the size of a cat. Rattus is relatively small.
Sure.
In a one-on-one cage match, I am absolutely betting my money on the giant Caribbean rat.
And in a pure physical cage match, you'd be right. Ekbletomys wins easily. But evolution and extinction isn't a cage match. It is a numbers game.
A numbers game.
And Rattus is the ultimate biological cheat code in the numbers game.
How so? Unpack their strategy.
First and foremost, rapid reproduction.
They breed fast.
Insanely fast. An island giant like Ekbletomys, having lived with 0 predators for millions of years, almost certainly evolved a very slow life history.
Because they didn't need to replace themselves quickly.
Right. They likely had fewer babies poo litter, a much longer gestation period, and took a longer time to reach sexual maturity.
Whereas the European rat
Explodes in population. The giants simply could not reproduce fast enough to sustain their numbers under new pressure.
they just swarmed them.
Swarmed. Second, Rattus is a highly aggressive, hyper-adaptable generalist. They will eat literally anything.
So they stole the food.
They absolutely would have outcompeted Ekbletomys for the seeds and plants it relied on. But much worse, European rats are notorious egg and nest predators.
Oh.
They likely hunted and ate the juvenile Ekbletomys right out of their nests before they could ever grow into giants.
So they cut off the next generation.
And finally, perhaps the most deadly factor, disease.
Biological warfare.
Almost certainly. Rattus carries a whole host of continental pathogens, fleas, and viruses that the native, isolated island rodents had absolutely 0 immune defense against.
It's the exact same tragic story as the human populations of the Americas encountering European diseases.
It is a terrible parallel, yes.
So the extinction wasn't a giant battle. It wasn't a bang. It was just a whimper, a slow, choking, inevitable squeeze.
A deadly squeeze. But one that happened incredibly fast in geological time. Within just a few short decades of European ships dropping anchor, a unique biological lineage that had successfully survived for millions of years was completely wiped out.
And it wasn't just limited to Antigua and Barbuda, was it? The outline mentions this mysterious, undescribed species B showing up elsewhere.
Yes, and this is where the scale of the tragedy really widens.
What did they find?
In recent years, archaeologists digging in middens on other islands, specifically Guadeloupe, Montserrat, and Marie Galante, have found the scattered bones of a very similar, massive rice rat.
Also labeled undescribed species B.
Exactly. The morphology is so close that it strongly suggests that either Ekbletomys itself or its very, very close cousins were actually the dominant ground mammals across that entire section of the Leeward chain.
They weren't just a localized fluke. They were a regional empire.
They were a massive evolutionary success story. They had conquered multiple islands. They were everywhere.
And they all fell to the exact same enemy.
The dark sediment layer is found in the caves of all those islands. The story is identically grim across the board. The wooden ships arrive, the European rats disembark, the native giants completely disappear.
It really brings us right back to the start of this entire conversation, the profound irony of this animal's existence.
It is deeply, deeply ironic if you just take a step back and look at the resume of the species.
Let's review it. It starts out as a small, shivering rat in the high, misty cloud forests of the Andes.
It gets swept into a raging river, survives a brutal, seemingly impossible Sinbad voyage across the ocean on a tangle of roots, a literal miracle of survival at sea.
It washes ashore, a castaway. It conquers an entirely new, alien landscape.
It fundamentally changes its own biology. It reshapes its skull, alters its teeth, and blows up its body size to completely master that limestone terrain.
It survives massive Caribbean hurricanes. It survives the rising sea levels at the end of the global ice age when the islands shrank.
It even survives the arrival of the first spear-wielding human hunters living alongside them for thousands of years.
It survives all of that. But it could not survive the year 1500 AD.
It could not survive the globalization of the common rat.
And now, the final, most bitter irony of all, it can't even survive the rigid bureaucracy of human science.
It sits quietly in a museum drawer, permanently unnamed.
A literal ghost species.
It really is a poignant reminder that extinction doesn't just physically erase the living animal from the earth. Sometimes it eventually erases the very memory of the animal from our records.
Which is terrifying.
Think about it. If Clayton Ray hadn't been incredibly diligent in the 1960s, if he hadn't written that specific, brilliant thesis, we wouldn't even know enough today to call it undescribed species B.
It would just be a box of weird, oversized bones gathering dust on a shelf.
Just a geological anomaly nobody bothered to look at closely.
And that is the one thought that I really cannot shake as we wrap this up. We only know about this specific ghost because Ray was diligent, but how many other drawers are out there?
Oh, that is the big open question in paleontology.
I mean, every major natural history museum in the world, London, Paris, New York, Washington, D.C., they all have massive labyrinthine basements full of what they call unprocessed material.
Millions of specimens, boxes of bones collected hastily by explorers in the 1800s, fragile fossils dug out of quarries in the 1920s that got packed away during a war and never opened again. They're all just sitting there in the dark.
Waiting for a name, waiting for a story.
Exactly. How many other forgotten ghost species are currently hiding in plain sight? How many other impossible Sinbad voyages are locked away in a steel cabinet right now, just waiting for a curious grad student to pull open the drawer, take the millimeter measurements, and finally write the right paper?
We tend to romanticize exploration. We think it means going out into the unmapped jungle with a machete and a pith helmet.
But sometimes the most important exploration is just going down into the climate-controlled basement with a pair of digital calipers and a strong cup of coffee.
The history of life on Earth is far from finished. It is still being written, and a huge chunk of it is going to be found quietly waiting in the archives.
I couldn't agree more.
Well, here is to Ekbletomys, the cast-up mouse. May it one day finally get its official name on the deed.
Hear, hear. I hope so, too.
Thanks for taking this deep dive with us today.
It was my absolute pleasure.
And we will catch you all on the next one.